Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Nvidia, and we're here today to talk about SC13, and we have Sumit Gupta. He is the general manager of the Tesla Accelerated Data Center Computing Group. So, Sumit, welcome to the show. Welcome back, I should say.
Thanks, Rich. It's great to be here.
Well, we're all gearing up here, and I think by the time people hear this, a lot of us will be in Denver. But why don't we go through your slides and then follow that with Q&A?
Sounds great. So let me get right into it. So we have a lot of news coming out right now, and I've actually put it into three buckets. And one of them is an announcement with IBM. The second is some new products we're announcing, and lastly, but not least, some new supercomputer announcements. Business is really growing. We have many more customers adopting the technology. In fact, a recent survey by Intersect 360 showed that the number of systems with accelerators has doubled in the last 1 year. And NVIDIA GPUs are the preferred choice for nearly all these systems. Xeon Phi is just at 4% of the systems in the market. We think that this is happening because of the number of developers. You can develop on an NVIDIA GPU in your laptop. Every GeForce that we ship has the CUDA technology in it. So the number of applications has really blossomed for NVIDIA GPUs. It's with this backdrop that we have the first announcement. IBM, the third largest software company in the world, is announcing that they will accelerate a whole portfolio of enterprise and data analytics applications using NVIDIA's GPUs. So these are applications ranging from data analytics to risk analytics, and even application infrastructure things like a Java compiler. We're pretty excited about this because this really opens up the GPU accelerator to go beyond supercomputing and HPC into the big data analytics market and into the enterprise computing market. So that's one of the first big announcements that we want to go through.
Yeah, I'm just curious. I mean, with all those vector units in the GPU, how do the algorithms lend themselves to that kind of parallelism?
Yeah, they're starting with the low-hanging fruit, which is all the big data analytics applications. Those are very amenable to GPUs, but they think they already have done work on this, and they believe that there's opportunities to accelerate databases, data warehousing, the whole gamut. The second announcement actually is also with IBM, but this is from the systems group at IBM. So remember, IBM really is, I would say, at a very high level, three big companies. You have the software company, the systems company, and the services company. So talked about the software company, let's talk about the systems company. IBM is announcing that they're going to build their next generation of supercomputers with Tesla GPUs along with their Power 8 CPUs. So these will be Linux-based systems that will be available starting next year, 2014. This is, again, a very big announcement for the high-performance computing community because IBM remains the leader in the number of FLOPS, for example, in the top 500 are dominated by IBM systems. So they maintain the leadership position in supercomputing. This also complements the software offering by providing power plus GPU systems to the enterprise, which is also one of the strong suites of IBM.
So Sumit, what about these power systems? I mean, did you have to do something new with the form factor, or do they just have a PCI slot just like an x86 does?
Yeah, so they're putting enough PCIe slots. These are new systems that they're designing, so they're putting in enough PCIe slots to put our GPUs in. But it's no different. I mean, it's a standard server.
Yeah.
Most of the work actually is in the software. One is IBM is making sure PowerAid works well with Linux and Little Indian Linux to be exact. And the second is we're going to support the CUDA toolkit for power CPUs. Today we only support the CUDA toolkit for x86 and ARM. You know, with all of these announcements, the interesting trend that we expect next year is from going from just an x86 plus GPU system, we believe that next year we will have systems which will have x86, ARM64, and power along with GPUs for high-performance computing and enterprises. So we expect the diversity in the data center to dramatically increase. Now, the next piece of news that comes in is as big as the earlier stuff we talked about, and this is that the GCC compiler in Linux is going to get support for GPU accelerators. Mentor Graphics and Samsung are doing an open source and free implementation of OpenACC into GCC. GCC is obviously the default compiler in Linux, so it ships with every Linux distribution. And this really opens up GPU accelerators to every Linux developer. By default, in their installation, they'll get a free OpenACC compiler that they can start using to target NVIDIA's GPUs. So that was the first set of news. Let's move on to the next set of news. We also have some really exciting new products. So we have two new products. One is a hardware product and one is a software product. The hardware product is a new Tesla K40 accelerator, which has many unique things. I'll talk about it in the next slide. And the second is a new release of CUDA 6, in which I'm going to focus on one very important feature called unified memory. So let's start by talking about K40. K40 is the flagship accelerator that we're building, that we're going to start shipping this month. And it is faster than our current highest end, which is the K20X. It's more teraflops, over 1.4 teraflops, more CUDA cores, 2,880, and higher memory bandwidth. This aggregate gets you much higher performance on all real applications. The K40 also has double the memory of a K20X. So from 6 gigabytes, we've gone to 12 gigabytes. This opens up many more applications and enables applications with very large data sets to get accelerated by GPUs. And then we've added a brand new feature into the K40 called GPU Boost. GPU Boost gives you extra performance by tapping into the power headroom for real applications. We'll talk about that in the next slide. So the way GPU Boost works is the accelerator has a power limit of 225 watts. But most applications actually don't run at 225 watts. They run at a much lower power. So what we're able to do is run the GPU cores, all the CUDA cores, at a higher clock and therefore achieve higher performance on all these applications. In the examples shown on this slide, we are seeing speedups, extra speedups on using Boost ranging from 11% to up to 25% using GPU Boost. So given these three features, higher performance, larger memory, and GPU Boost, the Tesla K40 actually becomes the fastest accelerator available both for supercomputing and big data analytics.
So you're able to boost the clock rate for some of the vector units, or as long as you don't you go beyond that power limit?
We actually boost everything. So we boost all the CUDA cores at the same time. Mm-hmm. I know that CPUs have only some of the cores get boosted, but what we did was we actually built it so that all cores boost, and that way you get consistent performance.
And then, is there a cooling issue when you overclock on something like that?
No, because what we're doing is these really aren't overclocked states. They're actually just higher clocks where we know that these applications will not exceed the power limit.
Yeah.
The power limit is still 225 watts.
Mm-hmm.
And so what we did is we took a bunch of applications which are representative of the apps that run on real systems, and that's how we figured out what are the higher clock states to pick. So, it's not any clock frequency. There are fixed clock frequencies that you can choose. So that was the K40. Let me move on to the next announcement. And this announcement is a brand new developer feature called Unified Memory, which is available in CUDA 6. So CUDA 6 will be available to early developers next week. And what Unified Memory does is it significantly reduces developer effort while programming GPUs. One of the big challenges that developers have faced with GPU accelerators is that they have to deal with two memories. One is the CPU and system memory, and the other is the GPU memory. So they have to do a lot of data management and memory data movement between the two memories. With Unified Memory, now the developer actually sees a single pool of memory and is able to just operate on the data. The underlying drivers and associated software actually does the data movement for the developer. So a developer can focus on the algorithm and the operations, and the software takes care of actually moving the data from the CPU memory to the GPU memory or vice versa. This really reduces the lines of code. Some developers have told us that this actually reduces their programming effort by almost 50%. So this is a feature that a lot of developers have been waiting for a long time.
Now, Sumit, is that just on the new hardware, or where does this come into play?
This is available on all Kepler hardware with CUDA 6.
Okay.
Yeah. Just to illustrate the point, with CUDA 6, the change in the code from CPU to GPU, the additional lines of code for this simple example is just one additional line of code. But, without this unified memory, this would have required another 5 or 6 lines of code which were just dealing with data movement, just to give you an idea of how much simpler it is.
Yeah, so all of that's happening in the background by the... Is it the compiler that does that, or which piece?
It's between the compiler and the driver. So the compiler picks up some of it, the driver picks up some of it.
Sure.
It's a pretty complex interaction there. So this feature has been something we've been working on for a long time, and we believe that this is a significantly, in particular, improves the day zero experience of developers. In other words, when they start using GPUs, they no longer have to deal with the memory management. They can just focus on just programming the GPU or taking advantage of the GPU.
Yeah, because if you had to, even on the CPU side, if you always had to do that, that could get pretty tedious, right? Loading registers and everything like that. You don't have to worry about those functions. So
that's right.
Very cool.
So there's many other features in CUDA 6, but I focused only on unified memory today, and because that we've added for developer productivity. So now let's get into the third set of news. There's a bunch of new supercomputers being announced next week that are using Nvidia's Tesla GPUs. I'll focus on two. So the first one is a new supercomputer at the CSCS lab in Switzerland. So this is the Swiss Supercomputing Center. And this new system, the PISDENT, has achieved in their latest LinPack run over 6.2 petaflops of performance. They've submitted many versions of this, so we don't know what will be in the eventual top 500 list. But they recently ran it and they got a 6.2 petaflop run, which actually puts them at 80% LinPack efficiency, which is much higher than any other accelerator-based system has achieved, right? Most accelerator systems have been in range. This also makes PISDENT the fastest supercomputer in Europe. The current number one, I actually forget which one is the current number one, but this is quite a bit ahead of the current number one in Europe. Quite an achievement for a Swiss supercomputing center. It also is the greenest petascale system. So the greenest petascale today is the Duke Queen at Jülich. And the CSCS PS-Dent is much more energy efficient than that system. As you can see by the numbers on the slide, it's over 3,000 megaflops per watt. The folks at CSCS have already done many science runs, including a production-grade weather model called Cosmo, which is used very broadly throughout Europe. So they've already starting to get scientific results out of the system.
So Sumit, how are they able to get that 80% LinPack efficiency? Is that in part due to the Cray Cascade architecture? I mean, with their interconnect and the combination of the new Kepler GPUs.
Yep. So a few things improved here. One is they actually are using the CPU is better than the older Cray systems, and the interconnect's better. The cooling on Cascade is better, and this is actually CSCS uses liquid cooling at the cabinet level. That's how they get the greenness actually, energy efficiency. I mean.
Sure.
But the LinPack efficiency is coming from mostly using obviously the most energy efficient Kepler. They used a K40X with a CPU that can keep up with it, and a network that can keep up with it.
Well, that's a great use case there. That machine. I think that's the one in Lugano that they cool with the lake water, right? That frigid water.
Exactly.
Yeah. Awesome.
And you must have seen there was a full public works project getting the water up from the lake to the center.
Oh yeah. There was a big tunnel they had to build there under the streets, right? So very cool.
Exactly. So the next supercomputer I want to highlight to you is a new system at Tokyo Tech called KFC. KFC is a nod to the fact that the Keplers, or the K, is dipped in oil. And this gets them to an extremely high energy efficiency, making this system the greenest supercomputer that we know of right now. It's over 4,000 megaflops per watt. The current number one on the Green 500 is around 3,200 megaflops per watt at Chinica, which also uses Nvidia Kepler GPUs and liquid cooling. But this system is able to beat that by using this new oil immersion technology. So it has no fans inside, and that removes a lot of the extra power that gets burnt. And yet another big achievement from one of our customers using our product.
So that's called the KFC system, as in Kentucky Fried Chicken?
I think the K stands for Kepler. I'm not quite sure what the F and C stands for, but KFC is pretty big in Japan, so...
Well, that oil must get pretty hot there, cooling down that machine. So.
Okay, the last piece of news I want to share with you is around a new application, which is ANSYS Fluent. ANSYS Fluent is perhaps the most widely used technical computing application in the world, and this is now accelerated by NVIDIA's GPUs, available end of this year, and the speed up is pretty good. But as with any of these simulation applications, the benefit goes much beyond the speed up, right? So an example here is 2 times more simulations of a car, the aerodynamics of a car, and you can reduce the drag by, let's say, just 2%. You can save up to 1.5 billion gallons of fuel every year. That's like $6 billion a year. So, 2x is quite a big deal in the world of digital manufacturing simulation.
And I suppose now ANSYS has gone in there and optimized that to run on the Kepler then. Right.
So we also built a library that they were able to take advantage of. So it was a collaboration between ANSYS and us. It's a library designed to accelerate a bunch of CFD applications.
Well, Sumit, I want to thank you once again for coming on the show today.
My pleasure, anytime.
You bet. We'll see you in Denver. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.